Our house example was one number in, one number out, but real data is huge. Inside a computer, all of it becomes one thing, a grid of numbers, and a grid of numbers has a name, a matrix. Start with something familiar. Open any business spreadsheet, rows and columns of numbers. That is already a matrix. Your Excel sheet is a matrix. Now a photo. A picture is just a grid of tiny dots called pixels, and each pixel is a number. 1,000 by 1,000 photo is a matrix of 1,000,000 numbers. Sound, text, tables, images, the computer turns every one of them into a grid of numbers. So when we say everything inside is a matrix, we mean it quite literally. And the magic is you can do maths on a whole grid at once. Want to brighten a photo? Add a little to every pixel. Want to find the edges? Multiply the photo by a special grid. One operation, the whole image. But these grid multiplications are enormous, millions of numbers at a time. That is exactly why we use GPUs. A GPU is built to crunch giant grids in parallel far faster than an ordinary processor.
And a single row or column, is that still a matrix?
Good eye. A single row or column is called a vector. A full grid is a matrix. And a stack of grids is a tensor. Hold on to that word tensor. We will need it very soon. So a model does its work on these grids, but what actually is a model once it is trained? Next, it is nothing but weights.